The next lecture is about bridge digital twins, and it will be given by Kamil Korus from Silesian University of Technology, Poland. Who knows, maybe in future digital twins will include that other different dimensions of BIM. Kamil, the floor is yours.
Good morning, my name is Kamil Korus and I am a PhD student at the Silesian University of Technology. In this presentation, I would like to describe the idea of digital twins of bridges. The vision of digital twinning already shapes the future of many industries. And it may also be a chance for digitization of our infrastructure to provide real benefits for designers, builders, managers, and finally, users of bridges. So let me start with a brief history. The idea started with NASA Apollo 13 program. Created simulators were meant to reflect the actual spacecraft. It helped NASA engineers to understand the spacecraft operation. It was the technical twin, the older brother of the digital twin. In 2002, Dr. Greaves presented the conceptual idea for product life management, which later transformed into the digital twin. As you can see, life management is important for digital twinning from its very beginning. From 2011, NASA started to use digital twins for aircrafts. And from 2013, we had first implementations for other objects. Today, digital twinning is a multi-industrial technique and is being implemented by industrial tycoons. Digital twins, as relatively young, are not yet strictly defined, but we can agree that digital twins are realistic, accurate digital representations of objects in the whole life cycle. However, for practical use, the definition may be less important than digital twins' features. As I said, digital twins are a multi-industrial vision, so the implementations share several features. However, from practical point of view, we shouldn't mindlessly follow the features, but rather adjust them for specific objects. And that is why defining specific frameworks, such as digital twin of bridges, is so important at this stage of development. It is worth noticing that some of the digital twins features are shared with BIM, Building Information Modeling. We have also some differences, but in fact, we can say that BIM on some level prepared civil engineering for adopting digital twins. For example, EFC, Industry Foundation Classes models, are a good basis for creating digital twins. Therefore, for civil engineering, digital twins are kind of evolution from BIM. Adopting digital twins in civil engineering is important because of interoperability, one of the features. Technologies are becoming more and more interdisciplinary, so also the models will collaborate more with themselves. We may imagine a digital twin of a bridge collaborating with a digital twin of an autonomous car. There also will be sub and over relations when one model contains another. For example, model of a bridge will contain models of its SHM measurement tools. But on the other hand, the model of a bridge will be a part of the bigger system. For example, digital twin of smart city. Digital twins will cooperate on common standards of data management. Therefore, evolution from BIM into digital twin is needed to enable and standardize this multimodal operation. Autonomy and self-evolution are features beyond the scope of BIM. The digital twin collects data from the whole life cycle of an object and therefore becomes a big data system. The data can be used for training intelligent systems to manage and optimize facilities. In such a way, a digital twin aggregates processes. It monitors past and predicts and reacts on the future. Thanks to increasing data, the intelligent systems can evolve and become more accurate and reliable. Next features, time synchronization and fidelity of models, are important in the context of practical implementation. These features should be adjusted considering characteristics of the specific object. In case of bridges, the in-time synchronization of the model and real structure is not so needed. Also, it is not needed and practically impossible to reflect all the details of a real structure. This ultra-synchronization and ultra-fidelity are not practically crucial, but could affect the costs of implementation. And big, not justified costs can result in neglecting this technology by infrastructure managers. Here, it is important to keep the theoretical, practical aspects balanced. Nevertheless, it is important to discuss another aspect of data collecting. Because of the very rapid development of science and technology, we cannot predict with the complete confidence which data can be useful in the future. Perhaps new calculation theories will be presented based on newest analysis. Perhaps machine learning systems will detect patterns neglected by people. Digital twin should be able to expand its functionalities, also basing on data which today may seem not so useful. And even though the balance of implementation cost is important, when designing digital twin systems, we shouldn't neglect any additional data. If it's possible to collect it with design methods, it should be done. So these are the features showing the vision of this civil engineering digital twin. But to enhance the real development, we need something more than just theoretical frameworks. The most important are practical engineering adoptions. And they are becoming more common thanks to the technology development. Point clouds, virtual and mixed reality, machine learning, big data, but also Internet of Things, cloud computing, or blockchain. This all can be incorporated into our bridges designing, creating, and management through digital twins. So digital twins of bridges are still in its infant stage, and this is the right time to define how they should be to provide real benefits in the whole life cycle. Civil engineering digital twins can inherit from building information modeling, but BIM is not the same as digital twins. And we need to encourage this evolution to enable multi-industrial collaboration, in which bridges will be a part of the unified digital world. Thank you.
Thank you, Kamil. I'm really excited about the idea of digital twins, especially for bridges.